Hello and welcome to Algebra 1, Lesson 59. In this video, we're going to learn about using rational numbers as exponents, which is also known as working with fractional exponents. All right, so we're going to kind of just jump right in. This is not a very hard topic to wrap your head around, and it's something that is going to dramatically increase your speed when you're simplifying radicals moving forward. So let's suppose we saw something like 3 to the power of 1/2 times 3 to the power of 1/2. So at this point, we have all the tools that we need to simplify something like this. Now, we know that from the rules of exponents, we would keep our base 3 the same. So that stays the same. And then we would add the exponents, right? We would add the exponents because we're multiplying. So this would be 3 to the power of 1/2 plus 1/2. Now we already have a common denominator, so this is pretty easy to do. This would be 3 to the power of 1 plus 1 is 2 over the common denominator of 2. And then 2 over 2 is just 1. So this would be 3 to the power of 1, which is just 3. Now, having seen me do this example, what can you guess is going to be another way that we can write 3 to the power of 1/2? Well, it's going to be the square root of 3, right? Because the square root of 3 times the square root of 3 is going to equal what? At the end of the day, it's going to equal 3. Square root of 3 times square root of 3 is 3. Square root of 2 times square root of 2 is 2. Square root of, let's say, 4 times square root of 4 is what? It's 4. And we know this one because the square root of 4 is a rational number. This would be 2 times 2, which we know is 4, right? So we can prove the rule by looking at that. So in each case, I could rewrite these. I could say this is really 2 to the power of 1/2 times 2 to the power of 1/2, which equals 2, right? It's 2 to the power of 1/2 plus 1/2, which is 2 to the power of 1. In this case, I can say this is what? It's 4 to the power of 1/2 times 4 to the power of 1/2, which is 4. So having a number raised to the power of 1/2 is the same thing as taking the square root of the number. It's just how we write it with exponents. Now, as something that's a little bit more complicated, let's say we stay with the number 3. And we saw 3 raised to, I don't know, let's say the 1/3 power. Okay, the power of 1/3. So then I would multiply this by 3 to the power of 1/3 again, and then one more time. So again, using our rules for exponents, what would this be equal to? Well, I have the same base, so that stays the same. And then I would just add the exponents. So 1/3 plus 1/3 plus 1/3 is equal to what? It's equal to 1, right? 1 plus 1 plus 1 is 3. 3 over that common denominator of 3 would be 1. So this is 3 to the power of 3/3, which is equal to 3 to the power of 1, or just 3. So after having seen the last example, what would you guess is another way that we could write 3 to the power of 1/3? We could do the cube root of 3. The cube root of 3, right? Because the cube root of 3 times the cube root of 3 times the cube root of 3 is equal to 3. So now that we've seen a few examples, let's define our first rule. So we want to let a be greater than or equal to 0. So this just means that a, which is right here, is going to be non-negative. And then we're also going to say that n is going to be positive. Okay, it's going to be a positive integer more specifically. Now, so that means that n can't be 0. And n is in the denominator, so that's why it can't be 0. And also n is not going to be negative. Okay? Now, when we have these conditions that are met, we can say that a raised to the power of 1 over n is equal to the nth root of a. So in other words, this, when we're looking at it in exponential form, is the base. And when we transform it over to this format, it's going to be the radicand. Then here, n is your denominator. This is the denominator. And when we move over here, it becomes the index. Now, I suggest that you write this particular thing down on a flashcard, okay? And what you want to do is, as we go through the examples here, keep your flashcard out, pause the video, and then try to do it yourself, okay? You can even do this when you're doing your practice problems or your homework, okay? After about 10 problems or so, you're going to memorize this generic formula, and you're going to do this without having to look at that flashcard. So let's start out with 216 raised to the power of 1/3. So we know that this is going to end up being our radicand. Okay, so let me write 216. And let me write the radical. And we know that 3 is going to end up being the index. Okay, that's going to end up being the index. Okay, again, just straight from your flashcard. So we end up with the cube root of 216. And most of you know at this point that that's going to be 6. Right? That's going to be 6. 6 times 6 is 36. 36 times 6 once more is 216. What about something like 625 to the 1/4 power? So again, this part right here would be the radicand. And it would be the 4th root, right? Because this would be your index. So again, this would be the index. And then this would end up being the radicand. So I have the 4th root of 625, and that's equal to 5, right? 5 times 5 is 25. 25 times 5 is 125. And then 125 times 5 is 625. What about 169 to the power of 1/2? Again, we know this is the same as just taking the square root of the number. Raise something to the power of 1/2, it's like taking the square root. So I'll put equals the square root of 169. And again, if you didn't remember that, you could use the flashcard and say, okay, well, this is going to be my radicand. And then this, the denominator, is going to be my index. Now, when we work with square roots, we know that we don't display the 2, right? We have an understood index of a 2 when there's no index that's displayed. So we all know that the square root of 169 would be 13. What about 243 to the 1/5 power? Well, again, this part right here, this 243, would be my radicand. Okay, this would be my radicand. And then I'm taking the 5th root of that, because this right here, my denominator, would be the index. Let me rewrite that, make it a little cleaner. So what is the 5th root of 243? Well, again, it's 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And then 81 times 3 is 243. All right, for the next one, let's look at negative 512 raised to the power of 1/3. Now, when I gave you the rule, I specifically said that this value here, which is a, when we talked about our rule, is non-negative. So what gives? Why is this negative? Well, I want to show you that you can also incorporate this rule with a negative. We just have to keep in mind that when you work with roots, remember, you don't want to end up with a situation where you have an even index and you have a negative radicand, right? That's going to produce a not real solution. Okay, so we want to kind of stay away from that for right now until we get into Algebra 2 when we can kind of deal with those scenarios. So I'm going to write the cube root of 512, and it's negative, so I'm going to put that in there. And this is okay because the negative there, when I think about a cube root, is fine, right? -1 times -1 times -1 is -1. So I can just put a negative out in front here, and then just think about 512. What is the cube root of 512? Well, in case you don't know that, and I know up to this point I just kind of gave you the answers, let's get a little practice in figuring this out. This ends in 12, so I know it's divisible by 4. And this would be 128 times 4. And I know that 128 is 2 to the 7th power. Some of you don't know that, so you could continue and say, okay, well, this is 64 times 2. And at this point, you should recognize 64 is 2 to the 6th power. So really, if I wrote this as 2 times 2, I could say I have 2 to the 6th power times 2 times 2 times 2. So really this is 2 to the 6th power times 2 cubed, or 2 to the 9th power. 2 to the 9th power. Now, here's where we can really kind of get things going, okay? If I have 2 to the 9th power, because that's what 512 is, forget about that negative for a second, and I took the cube root of that, how can I use what I just did to simplify that? Well, if I realize that I'm taking the cube root, and that's like raising something to the 1/3 power, I can keep this as 2 to the 9th power, and then I can raise this whole thing to the power of 1/3. Now, by the power rules for exponents, I know that I would multiply. This is like saying I have 2 to the power of what? 9 times 1/3 is 9/3, which is really equal to 2 to the power of 3, or 8. So this is going to equal -8. And the reason I did this way is because it's going to lead into what we're going to do next. Okay, I wanted to give you a brief example. So -512 raised to the 1/3 power is -8. So what would I do in a scenario where I have 9 to the power of 3/2? Well, just like in the last example, I'm able to kind of break this up using my power rules for exponents. So what I can do, just kind of look at this for a second, I can rewrite this as 9 to the power of 1/2, and then this is going to be raised to the 3rd power. And again, if you use the power rules for exponents, you'll see that you end up with the same thing. I'd multiply the exponents here and keep the base the same. This is equal to 9 raised to the power of 3 over 2, right? So I can go back and forth. But the reason I would want to write it like this is because it makes it obvious what I need to do, right? I know that 9 to the power of 1/2 at this point in your mind might still not register as the square root of 9. It does for me, but I've been doing this for a long time. So you might want to say, okay, this is the square root of 9, just following the processes we've been doing, right? 9 is the radicand, 2 is the index. Then, once I've written it like that, I can raise this to the 3rd power, and then it's completely crystal clear that this is 3, right? Square root of 9 is 3. That's raised to the 3rd power, or 3 cubed, which gives us a final answer here of 27. All right, let's try another one. We have 625 raised to the 3/4 power. Again, I'm going to break this up, and I'm going to think about this as 625 raised to the power of 1/4. And then I'm going to cube this. And again, I'm going to write this, thinking about this as the 4th root of 625. Again, this is the radicand, so that comes down here. 4 is the index. And then I'm going to cube this guy. So what is the 4th root of 625? Talked about that earlier, it's 5. So this would basically just be what? It'd be 5 cubed, which is 125. All right, so now let's look at the more tedious rule. You definitely want to write this down because this is one that takes a little bit longer to get down. So if a is greater than or equal to 0, so again, if a is non-negative and m and n are integers with n greater than 0, okay, so n is greater than 0 because we want it to be positive. So then we have this scenario. A raised to the power of m over n is equal to the nth root of a, and this is raised to the power of m. This is what we just did. Don't let these letters confuse you. If I was to write this as 9 to the power of 3/2, just like we just did, all I did was, 3 in this case is m. So 3 is going to go on the outside. N is 2 in this case. So it's going to be the square root of, right, that's my index. And the a in this case is just the radicand, it's 9. Okay, it's the same thing. So again, if you struggle with generic formulas like this, write it down, and then before you do anything, on each problem, just say, okay, my a here is 9. Write a 9, okay, write a 9 underneath. My m here is 3, write a 3 there. My n here is 2, write a 2 there. And then just translate it into this formula here. Okay, well, I have a 2 here, I have a 9 here, and I have a 3 here. Once you start doing that over and over and over again, this becomes really, really easy, okay? So especially if you struggle with these formulas, please do that every time. Now, for completeness sake, we know the answer to this. Square root of 9 is 3. 3 cubed is 27. Now, here's one you probably have not seen yet. So we have a raised to the power of a negative m over n. So we have this is equal to 1 over, we have the nth root of a, and this is raised to the power of m. There's no difference between this formula and this formula, other than we just take the reciprocal, of this guy, okay, and we raise it to this guy being positive. It's just like when we saw 2 to the power of negative 4. We took the reciprocal of the base, and we made the exponent positive. So really, to make this crystal clear, I could say, if I have a to the power of negative m over n, I could write this as 1 over a to the power of m over n, right? All I did was I took the reciprocal of the base, so I have 1 over a, and then the exponent just became positive. Instead of negative m, it's positive m. As an example of this, let's say I saw something like 27 raised to the power of negative 2/3. So following this, 27 represents a, the negative 2, the whole thing, is representing the negative m. Or you could say 2 represents m and you have a negative out in front, however you want to think about that. Then n represents 3, okay? So if I translate this over here, I would basically have what? I'd have 1 over 27 raised to the power of 2/3. And then if I said I had 1 over the cube root of 27, and then this guy would be squared, I'd end up with a final answer of 1 over the cube root of 27 is 3. So it'd be 3 squared, which is 9. So I'd end up with 1/9 in that scenario. The key to this is just to write down the generic formulas, match things up, and just go slowly, right? Just take it step by step. All right, what if we saw 9 to the power of 5/2? Again, I'm going to break this up. I'm going to say this is 9 to the power of 1/2, and this is raised to the 5th power. And again, this would be the square root of 9 raised to the 5th power, which is what? 3 to the 5th power, which is 243. What about 144 raised to the power of negative 3/2? Again, take the reciprocal of the base. So take the reciprocal of 144, that's just 1 over 144, and then raise it to the power of 3/2. Exponent's just going to become positive, okay? Just that simple. So then I break this up. I have 1 over, this is 144 raised to the 1/2 power, and then it's cubed. So I'm going to write this as 1 over the square root of 144, and then that's going to be cubed. And so the square root of 144 is 12. So this ends up being 1 over 12 cubed, which is 1 over 1,728. What about negative 128 raised to the power of 8/7? So again, I can break this up and say this is negative 128. Now this is inside of parentheses, so this guy is going to be raised to the power of 1/7. And then I'm going to raise the whole thing, let me just use brackets here, to the 8th power. And then let me write it in a better way for you, to where it's more familiar. This would be the radicand, the negative 128. And I would have the 7th root, because that's my denominator. And this whole thing would be raised to the 8th power. Now, we know that the 7th root of negative 128 is negative 2. So again, negative 2 is the result there. And then this is still inside of parentheses here, and it's raised to the 8th power. So when we raise it to the 8th power, we're going to end up with 256. And again, because this negative is inside of parentheses, this would end up being positive 256. All right, now let's look at a few with some variables involved. The same rules apply, okay? Just because you're working with variables doesn't mean it got more difficult. All right, so I have 2x to the power of 2/3 times 3x to the power of 4/3 times 2x squared. Now, we know what to do here. We're going to multiply the coefficients together. 2 times 3 is 6. 6 times 2 is 12. Then we have x in each case. So it's the same base. We're going to add the exponents. So I have an exponent of 2/3, an exponent of 4/3, and an exponent of 2, which to get a common denominator, I'm going to write as 6/3. 2 plus 4 is 6. 6 plus 6 is 12. So this is 12/3, which equals 4. So my exponent on x would end up being a 4. So I end up with what? 12x to the 4th power as my answer. What about something like 3m to the 5/3 power times 3m squared? 3 times 3 is 9. And then m to the 5/3 power times m squared. So we know m stays the same. We just have 5/3 plus 2. So I could write 2 as 6/3. So this ends up being 11/3. So 11/3. All right, what about this one? We have x to the power of -2 times y to the power of -1/4. And this is raised to the 1/2 power. Then we're multiplying by x to the power of -2 times x to the power of -4 times y to the 5/3 power. So the first thing I want to do is use my power rule here. So x stays the same in this scenario. And we have -2 raised to the 1/2 power. So -2 times 1/2. We know that this cancels with this. I'd have -1. So this is x to the power of -1. And then for y, I have the power of -1/4 times 1/2. So 4 times 2 is 8, so this would be -1/8. Okay, then times. Over here, if I have x and I have x, that stays the same. And then -2 plus -4 is -6. And then lastly, I just have y to the 5/3 power. So if I think about these two here, I can combine them using the product rule for exponents. I would have x to the power of -1 plus -6, which is -7. And then as far as y goes, I can combine these. So I'd have y to the power of, if I have -1/8 plus 5/3, what's that going to be equal to? Well, we've got to have a common denominator. So let me multiply this by 8/8. Let me multiply this by 3/3. I would get -3 over 24 plus 40 over 24. So this is 37 over 24. 37 over 24. So you can leave it like this, or you could write it as y to the power of 37 over 24 over x to the power of 7. Remember, you can drag this into the denominator and change the sign of the exponent. So if there's a -7 when it's in the numerator, when it gets dragged below into the denominator, it becomes positive.